This video is going to cover section 13.2, Measures of Dispersion. In the previous lesson, we talked about measures of central tendency, and those included mean, mode, and median. And while those are used often, okay, sometimes it's hard to measure certain things when you're discussing a range of topics, okay, so or a range of numbers. So in this lesson, we're going to learn about range, which is something you might have seen, and something also called standard deviation, okay? So first of all, we have the range. The range of a set of data values is the difference between the greatest value and the least value. So pretty much your biggest number minus your smallest number. And that kind of gives you an indicator of from what to what this data is being based on, okay? So I'm going to go ahead and just show you an example. By the way, this video is going to be largely based on examples that are already present, simply because there is a lot of calculations involved, and we don't want to make the video too long. Okay, so just follow along. So here we have some data, okay, of a soda dispensed from a machine, okay, in ounces. In two machines actually. We have a machine one, which has ounces of in some cup, 9.52 ounces, 6.41 ounces, 10.07 ounces. So these are just different number of ounces per cup that was dispensed per cup. Okay, this was machine one. Machine two has it 8.01, 7.99. So you can see that these are a little bit smaller. This right here is the average. This represents the mean. Okay, so the arithmetic mean that we saw before. So when they say 8 fluid ounces per cup that you're going to get served, that's the average of what it should be, but this is what actually happened. Okay, this is what actually happened in these two machines. Okay, so anyway, it says find the range of the numbers of ounces dispensed by machine one in table 13.5. So this is our table. So machine one is these numbers, and all we have to do is look for the biggest one and the smallest one. So you can see here that my biggest number in this column is 10.07. So we went ahead and got 10.07, and the least is 5.85. So there's that one. And you just subtract them. And you can see that right here. 10.07 minus 5.85 equals to 4.22 ounces. So that would be the range of machine one. Okay. If I asked you to find the range of machine two, you would do the same thing. So for machine two, okay, you would say, well, the biggest one I have here looks like it's 8.03. So 8.03 minus the smallest one. So it looks like that would be 7.95 actually. Okay, 7.95. And you would just subtract. So it looks like this would be 0.08, okay, ounces. So you can see that the range is a lot bigger for machine one than it is for machine two. And what could that tell us? Well, that could tell us that this one is more consistent. So while you might get, a cup that has a lot, you might also get one that has way less. So just some things to consider when, deciding on what machine you'd rather get your soda dispensed from. Okay. So let's go ahead and move on. So range is pretty easy. Okay, so now we're going to talk about something that's called standard deviation. Okay, so standard deviation is kind of like finding the range. As you can see with the example we did above, the range can be highly sensitive depending on what numbers we have. So if we have like a lot of numbers that are, really close to each other, and then we have an outlier, that's really going to skew the data as far as like, what's the actual range of most of what you would get. So standard deviation is less sensitive to that. So it's another measure of, of dispersion. Okay, and here's how we find it. We have a list of numbers. Okay, so that's this right here, x1, x2, all the way to x7. And this is a population of n numbers, meaning it's the entire population of a specific experiment with a mean of u. So this right here, let me get this one. This right here is super important. Okay, this is that mean that we were talking about. It can be notated with that little symbol. It can also be notated with this one, the one that we saw on the top. Generally, if you're talking about a population, I guess I can color code this. A population of n, you would use this formula right here. Okay. And if you're talking about a sample of the population, then you would use this formula here. Okay, so the formula goes as follows. You need to subtract, well, first you need to find the mean. Okay, and I'm going to go through the list right now exactly how that's going to work. But first you would find this value here, so this or this value. And then you would take the numbers that you have. So like for instance, these numbers here, so all these numbers, and individually subtract them from that arithmetic mean, okay? So that number minus the mean. And you do that for each one. And then you square them, okay? And then you add all that up. That's what this symbol means. This just means that you add everything up, add all up. It's the sum, okay? And then you divide it by the number of terms. If it's a population, you do n. If it's a sample, you do n minus 1. Okay? And it's a pretty lengthy process, not gonna lie. But fortunately for you, I think you only have one problem that you have to do with all this. Okay? So let's go ahead and look at the steps officially so you can see what I'm talking about. We have the procedure for computing a standard deviation. So step number one is to determine the mean of the n numbers. So that's going to be either this symbol or this symbol. Okay? Either one. Remember, this one, I believe, this one is for a population, and this one is for a sample of a population. So just be careful because if it says sample, like you can see this one says sample, you have to use the formula that has this. Okay? Step number two is for each number, calculate the deviation difference between the number and the mean of the number. So that's what we saw here, x minus this, or we can do x minus this, okay? Depending which one we're dealing with. Step number three is to calculate the square of each of the deviations and find the sum. So this is kind of like a 2-in-1. So this is where you do, after you've done this, you square them and then you add them all up. You can do x1, x2, and so forth, okay? Step number four, if the data is a population, so population, okay, then you divide the sum by n. If the data is a sample, that's this one, then you divide by n minus 1. Okay, and n is just the number of terms. This is the number of items we have in the set. Okay, last but not least, to find the actual the standard deviation is we find the square root of the quotient in step 4. So whatever you get from here, you just square root it. Okay, and that's where all that formula comes from. That's where all of this comes from, either one. So we're just going to go step by step in an example, and they're already done for us, but I want to go through it. Okay, so we have the following numbers were obtained by a sampling by sampling a population. So that means we're going to be using this one. Okay, 2, 4, 7, 12, and 15. Find the standard deviation of the sample. So step number one. Okay, step number one. I have a different color there. Was to determine the mean of n numbers. So that's what I'm doing first here. So the mean, okay, remember the mean is equal to this right here, that x with the line on top of it. So I went ahead and got these numbers, 2, 4, 7, 12, 15, add them up and divide it by the number of terms. So here n is 1, 2, 3, 4, 5. It's 5. So that's why we got that 5 here, okay? So this came out to 8. So this number is super important, okay? Step number 2 says for each number, calculate the deviation. So to subtract between the number and the mean of the numbers. So that means that I'm going to have to subtract each of these numbers. I'm going to have to subtract 8 from that. So let's see how that looks. Here's step number 2, okay? So there are my numbers, 2, 4, 7, 12, 15, to all my x's. And then here's that subtraction going on. So remember that our mean is 8. That's what we calculated above. So we do 2 minus 8, negative 6. 4 minus 8, negative 4. 7 minus 8, negative 1. 12 minus 8, 4. 15 minus 8, 7. So Just subtract it from these numbers, and that gives you these numbers right here. Okay. Step number 3 is to do the square of each and find the sum. So I'm going to have to square these numbers now. So these numbers, I'm going to square them. So here's step 3. I'm going to, I guess I can't really get it all on the screen, but there's step 3. Okay. So these are the numbers that I found in step 2. Step 3 is to square them. So negative 6 squared is 36, negative 4 squared is 16, negative 1 squared is 1, 4 squared is 16, 7 squared is 49. So we have to square and add. So if we add all these up, we get 118. And this is the sum of the square deviations. Okay, so we're almost done. Step number 4 is to see if the data is a population, divide by n. If it's a sample, divide by n minus 1. So in this one, it was a sample, okay? So that means we're going to have to divide by n minus 1, okay? So here's step 4. Because we have a sample of n equals 5 terms, remember there was 5 numbers, we do 5 minus 1, there's my n minus 1, is 4. Okay, so that 118 that I got, here it is, we divide it by 4, okay, and that gives me an answer of 29.5. Okay, and the last step, step number 5, is to take the square root of that. So we say the standard deviation of the sample is S is equal to the square root of this number, which comes out to approximately 5.43. Okay, and that's our answer. Okay. Please take note when it comes to the meaning of all this, you want to get a standard deviation as small as possible. So we don't really have anything to compare this one to, so I can't really say if it's a good measure or not. But if let's say you had two different standard deviations and one of them was 10, one of them was 15, you'd want to go with the one that's 10 because the smaller the deviation, that means that the results are relatively closer to the mean. So you want to go with the smaller one. Okay, just keep that in mind. You will have a question on that. Okay. Last but not least, we have something called variance. Okay. So the variance is another statistic we can use in measuring dispersion. And it's actually not that hard to find because it's equal to the square of the standard deviation. So if you can do the standard deviation, you already calculated the variance. Here are the notations for this. So this one represents standard deviation. So like the one we had before was what was it, 5.43, I believe. So this symbol means standard deviation. It's kind of hard for me to draw, but okay. This symbol is the variance of a population. So that's this word right here, this statistic variance. We won't go too much into what it means. It's pretty much just another indicator on on uh, on statistics for the problem that you're doing, but we do need to know how to calculate it, okay? And then you can also do these notations here. So instead of using this, you can use S, and instead of using this one, you can use S square, okay? So just to kind of go back to what this is now, it tells us it's the square of the standard deviation. So from our previous example, and I just kind of copy pasted this, we saw that the standard deviation was 5.43, okay? So the variance of this, okay, would just be 5.43 squared, but we should know what that is already because we're just going backwards. So it's going to be 29.5. So that's what we had for step 4. So pretty much step 4 will give you your variance. Okay. And that's it for this video, guys. There is a little bit more on how to do this on a calculator, but because we're going, we don't have access to the calculators right now, we're going to go ahead and just leave it simple. So range, standard deviation, variance. Simple as that. If you have any questions, let me know.